Okay, so if we're solving a rational inequality algebraically, we first have to get the 0 on one side again. That's essential. So for this example, you have to get x minus 4 over 2x plus 4. You have to subtract the 1 from both sides to get 0 on one side. And then you have to do some algebra to get this to be a single rational expression. So we're going to have x minus 4 over 2x plus 4 minus 2x plus 4 over 2x plus 4. So we're going to rewrite our 1 so that it has a common denominator. And we're going to have x minus 4 minus 2x minus 4 over 2x plus 4. And I want to know when that's greater than or equal to 0. So negative x minus 8 over 2x plus 4. I want to know when that's greater than 0. So you rewrite the inequality so you have a single rational expression on the left side and 0 on the right. Okay, so then we're going to find the zeros of f. So the zeros happen when the numerator is 0. So that happens when x is negative 8. And we want to know where the denominator is 0, because that's places where you're undefined or where you might have a vertical asymptote. So that happens when x is negative 2. So those are the 2 points that you need on your number line to do your testing. You need negative 8 and negative 2. So our intervals are from negative infinity to negative 8. Negative 8 to negative 2, and negative 2 to infinity. So these are my intervals. Here's my test point. So I'm going to try negative 10. And I'm going to go back to my inequality and say, let's see, if I put negative 10 minus 8 over 2 times negative 10 plus 4, is that positive? So I get 2 on the top and negative 4 on the bottom, so that's not true. So this is false, and we don't want this piece. Okay, then from negative 8 to negative 2, you're kind of stuck with using something that's going to be more of a pain for your arithmetic. But well, let's just pick negative 4 and see how that goes. So let's pick x equals negative 4 for our test point. So I'm coming back to my inequality and saying negative 4 minus 8 over 2 times negative 4 plus 4, and I want to know if that's positive. So I have negative 4 on the top and negative 4 on the bottom. So 1 is bigger than 0, and I'm getting true for this interval. Okay, then from negative 2 to infinity, 0 is a nice easy value to try. So if I put 0 in, I'm going to get negative 8 over 4, and that's definitely not positive. So I get the interval from negative 8 to negative 2. Well, I want the negative 8 because that makes the numerator 0, and that's fine because that's the or equals 2. But I don't want the negative 2 because that would make the denominator 0. So my set notation will be the set of all x such that x is at least as big as negative 8, but no bigger than 2. And then my number line solution set representation looks like this. So then we'll work on this last example in class so that you have a chance to experiment, and we'll draw some of these graphs in Desmos so you can see what they look like.